The project departments of most major shipyards have already established concepts for the next generation of ships. But what will the vessels to be launched decades from now look like? What kind of floating structures are good new building prospects for the European shipbuilding industry? What types of know-how and technologies will have to be developed to build such vessels and structures? How will these futuristic designs meet the anticipated challenges? These questions about future European shipbuilding, bundled with commercial scenarios, provide the impetus for future maritime knowledge and designs. To stimulate thinking about the far future and visionary concepts for ships and floating structures, a think tank for the European shipbuilding industry has been established with the support of 6th Research Framework Programme of the European Union. This is the Visions Network of Excellence. In a cyclic process, 10 to 20-year market and society scenarios are created each year by experts for 5 business areas. Based on these scenarios, students of the European maritime universities are invited to respond to the scenario challenges with project ideas, creating a European idea contest. The best ideas are shortlisted and validated by experts who evaluate the most interesting aspects of the proposed concepts in more depth. Finally, 3 winners will be selected by a high-level industry jury, and all ideas will be presented to the European shipbuilding industry, which may then further develop ideas with the teams on an individual basis. Visions is managed and facilitated by industrial core partners who provide contacts to the business world. Visions links industry and maritime universities. With the Visions Network of Excellence, the European shipbuilding industry, kindly supported by the European Commission, has implemented a think tank to tackle far future challenges early enough to be prepared and set the pace, pairing the creativity of students with the expertise of specialists and industry management. In the 2008 contest, which was the 3rd ever done in Visions, 24 student teams from 8 countries submitted their ideas. The Visions partners selected 9 of the ideas for the shortlist, which then were evaluated by subject matter experts. Among the shortlisted ideas were the MAG Canal, a new propulsion system for inland waterways. Connect, a marine transportation system consisting of feeders, LDC and hub. Cruising with Wings, a trimaran-type sailing cruise ship. Floating Waste to Energy, a floating ship-shaped vessel for waste treatment. Anahita Island, a truly green holiday experience. Topless Hein Moana, a superstructureless tanker. Hydrogen production offshore structure, a jellyfish-shaped offshore structure. Innovating marine propulsion system, a redesign of an existing water jet propulsion system. Thermal offshore station, a structure for capturing and cultivating of undersea freshwater. Out of these ideas, an independent high-level industry jury selected the 3 winners of the 2008 Cesa Smart Award, sponsored by Bureau Veritas. A water jet is a well-proven device for the propulsion of high-speed ships. However, it is limited in efficiency due to vortices and turbulences inside the pump unit, as well as due to the reduction of jet stream area by the pump impeller shaft. The project aims to redesign this marine jet propulsion system. The main idea is to replace the pump by a rim drive. The rim drive tunnel thruster is a fully integrated system combining electrical, mechanical and hydrodynamic elements. The electrical motor takes the form of a thin ring mounted in the tunnel. The stator carries the permanent magnet rotor in water-lubricated bearings, and the rotor is fitted with propeller blades that point inwards. With this innovative design, the inventors hope to achieve substantial advantages compared to a conventional water jet design. For instance, higher efficiency, lower engine emissions, better maneuverability and better redundancy. Water is an essential element for all forms of life, including mankind. The world's population needs water for various purposes, such as agriculture, industry, household, and also for recreational and health activities. Most of the water on our planet, approximately 89%, is salt water. The most needed fresh water is a very limited resource, in particular considering that the human population will rapidly grow from 6 billion in 2000 to estimated 9 billion in 2050. Some years ago already, scientists have discovered subsea sources of fresh water. Meanwhile, they have developed the knowledge to capture and cultivate such subsea water wells. The project proposes to design and install a large floating structure for the full-scale exploitation of suitable subsea freshwater sources. The so-called thermal offshore station, which is intended to be supplied completely by renewable resources, could be a future basis for marine freshwater production and shipping. But it could at the same time serve as a large floating wellness oasis, benefiting from the healthy thermal properties of the fresh water wells. Hydrogen is an important future energy carrier. Pure H2 is produced from water or hydrocarbons and hydrogen sulfide, which requires the availability of sufficient energy supply from other primary carriers such as oil, gas, coal, nuclear or renewable. Many primary resources for hydrogen production massively exist offshore in deep water, often around underwater oil and gas fields. The project proposes a circular-shaped offshore floating structure for the production of hydrogen close to subsea resources of raw materials. The location is proposed to be in the Black Sea, where the total hydrogen energy potential is approximately 270 million tons, produced from 4.6 billion tons of hydrogen sulfide found in Black Sea deep waters. The hydrogen energy potential is equivalent to 1 year consumption of coal for production of district heat in Germany, or about 2 years of electrical energy consumption of the USA. The products produced on the platform are pure hydrogen, to be exported by pipeline, and sulfur, which will be stored in tank barges and be shipped later. To enable the use of renewable sources for the process energy, the platform concept combines wave energy converters and solar panels for the necessary power generation.